Hello everyone. Welcome to the course of Basics of Identity and Access Management IAM for web applications. Okay, so to discuss the agenda of this course, we will cover a lot of different topics about IAM, but generally this is going to be the agenda. We will start with the identity. So what is an identity? Is it a username, password, email address, etc., etc.? Then what is authentication, or it's also called auth-n, which is about giving the username and password and then the system authenticating based on that. Number three is authorization, which is also called auth-z, which is about giving access to the application and different levels of access to the application. So it could be admin access where the user could do anything, or it could be write access where the user could write to the application, or it could be only read access, or there could be many different types of access, which is authorization. Number four is identity provisioning, which is about adding the adding the account to the application. So how an account is added to the application for hundreds or thousands of users and how it is removed or revoked. Then it's directory services and LDAP, which is about Active Directory and LDAP. And at the end, it's delegated authentication. Although this is not going to be the end because we want to keep this course updated with latest technologies like OAuth and OIDC and Azure and other cloud technologies. But generally, we will be talking about these topics. Welcome back. So on this slide, we have actually shown the big vendors who have provided solutions for IAM. But before I dig into these vendors, I want to highlight that why IAM is a hot topic in cybersecurity. So as per the latest research in 2023, there are two topics where the CISOs or the security leaders have shown interest and have mentioned that these two topics or fields is where they will be spending most of their money in next 1 year or so. Out of that, 46% CISOs or security leaders have mentioned IAM as the area where they are going to spend more money in next 1 year. And the second topic is cloud security. So 46% people mention IAM and other 46% people mention cloud security. And in this topic, we're going to cover both the major products in IAM, major technologies in IAM, and how IAM in cloud is important and how it is used. But again, before I start to dig into more of these topics, this presentation or this training is actually for business users or newcomers who wants to understand IAM from a 10,000 feet, but not going to cover the details of these technologies. We're just going to touch how these technologies work at a general level and why we need these technologies in an enterprise rather than how to configure these technologies. That is going to be a different course altogether. This is for business leaders or freshers who have never touched IAM but need to understand what is the importance of IAM. Okay, then going into this proper slide, you can see these vendors who have given the solutions on IAM side for last few years or decades, and they are the leaders. There may be few other companies, and definitely there are few other companies, but these are the leaders. So starting with Okta, this is an open source solution company, and they provide different IAM solutions, and anyone can go and configure them if they want a free solution. One of the most expensive solution is SailPoint, which is showing here at number two. And companies are spending maybe in millions to get this solution for just 1 year. And usually it's not just for 1 year because once someone buy the product, they want to run it for 3 years or 5 years, and that is how the contracts work. Then the other solution is Auth0 ForgeRock, which is also an open source one, Azure Active Directory, which is part of the cloud, but it's very famous and very much used by enterprises. CA Technologies, which used to be the leader in IAM solutions and still used by a lot of big companies. Ping Identity, again, another big company and providing different solutions for enterprises. And then CyberArk, which is for privilege access management. So welcome back. We start with basics for a monolithic web application. So if someone is going to design a web application without using any of the enterprise available solutions, how would a web application handle everything? And in this diagram, you can see that. So on the left side, you can see there is a user, and the user is going to log in on a web application, which the web application will provide. Below the web application, you can see there are a few functionalities which the web application right now is handling. Business logic, which obviously the web application needs to handle and save the information in the database, which is application data. Number two is user authentication. So when a user gives a username and password, the application has to check if the username and password is correct. And where does it save that information? It's also in the same database and as a user identity. Number three is user authorization, which is, does this user have full access, read-only access, write access, and to which all parts of the website or web application the user have access. That is based on the user roles, which is also saved in the database, same database, the application database. And the last point is identity provisioning, which is about adding new users. Here we are only showing one user, but there could be 10 users, 100 users, or 1,000 users in future. For now, in a monolithic application, everything is handled by the same web application. This looks very old, but just to remind you, this kind of technology or this kind of architecture is still being used by some people. Welcome back. So now compared to the last slide, here we have four different applications, application 1, 2, 3, 4, and corresponding databases, database 1, 2, 3, and 4. We have 3 users in this scenario. And you can see one user is connecting to different applications, not just one application. The scenario in last slide was a bit simple because there was only one application and one user. But this kind of scenario exists in enterprises or big companies where there are multiple users and multiple applications, and usually thousands of users and thousands of applications. This is not practical to have the same username and password to connect to multiple applications. Example, you can see this user 1 is connecting to application 1 and application 2, and on the right side, extreme right side, you can see there is a user 1 and the password is u1p1. For the same user on application 2, the password is u1p2. And same way, you can see different users have different passwords, but how difficult it is to manage this kind of infrastructure, not just for the user, because the user need to remember multiple passwords for different applications. There is no single sign-on here, but also for the application developers, because they have to manage multiple users, and every developer for every application, it could be the same developer or different developer, but they have to manage the users independently for each application. In next few slides, we will understand what are the problems with this kind of architecture. Welcome back. So in this slide, we're going to look at 6 problems in this architecture. Although there are more problems, but let's just focus on 6. You can see the problems highlighted here in green color boxes. Number 1 is user identity is duplicated. As you can see, user 1 exists for application 1, again for application 2, and same with for other applications wherever user wants to access that application. So there is definitely a duplication of user identity, which is waste of resources, waste of time, and complexity for everyone. Okay, moving on to number two problem, which is user has to remember too many passwords. As you can see here, if user one wants to connect to application one, need to remember a different password, user U1P1. And for application two, needs to remember the other password, U1P2. Although user could use same password for all the applications user want to connect to, but remember here, these applications are designed by same or different developers, and they can decide to log the passwords and usernames. It all depends on how they write the code. So in that case, a developer for application one could know the password for that application, and maybe the user wants to use the same password for other applications. This is definitely wrong for a security architecture. So that's problem number two. Now going to problem number three, which is application is responsible for user provisioning. As you can see here, for every user who needs to connect to this application or any application, the application developer have to create an account or provision the account for all the users. It could be 10, 100,000 users, but the application developer had to create one by one all these accounts or in an automated way, but it's going to be the application developer's responsibility. Okay. And then going to number four, which is no single sign-on. That's problem number four, because once the user types login information, username, password to connect to application one, the user need to do the same thing for application two and other applications. And even for the same application, they have to type again and again because there is no single sign-on to use in this architecture. Problem number five, application responsible for multi-factor authentication. So if in case the application wants to use MFA, which is two-factor authentication, for example, using a token, using a push notification, or using fingerprint, that logic has to be added to the application. And number six is credentials are sent to the application, which is a security problem because now application developer decides if they want to log the username and password because it's directly sent to them using a login page which is shown by the application. So in summary, these are the six problems we're going to focus in next few slides. And that is the core understanding, like why we need these smart identity and access management solutions for covering identity problems, authentication problems, and authorization problems. Welcome back. So the first topic to solve the six problems is common identity. So we need a common identity which can save all the usernames and passwords for all the users which need to connect to these applications. If we have a common identity, a lot of these problems would be solved. And the web applications just have to connect to the common identity instead of saving the username and passwords in individual databases. Welcome back. Now to solve a few other problems, you can remember that the bottom part of this slide is same as what we saw a few slides back, which is where we have a username, where the username has to give login information. Then we have the web application, and then we have a database. But now you can see that some of the functionalities of the web application have moved out. User provisioning have moved out to IDM provisioning solution. User identity and user groups have moved up to directory. And these green boxes are actually newly added boxes or solutions which have taken on few of the functionalities from web application. So a directory service, which is Active Directory in most of the cases, but it could be any other directory service also like LDAP, etc. So the functionality of a directory service is to give the authentication and handle the information of user identity like username, password, and user groups. And we need another solution for provisioning and deprovisioning, which will create the accounts for the user to access the application. We will discuss in next slide what all problems are solved by this architecture and what all problems are still remaining. But just to understand, this is all in one data center or one organization. That is why the web application can trust the directory service solution and pass on some of the functionalities like user provisioning and authentication part based on the identity saved and role information saved in the user groups. Welcome back. So this slide you have already seen few slides back, but you can see there is a tick mark now against few of the problems. So three problems we have already solved till now. Number one, user identity is duplicated. That is solved because we have a common identity now. Problem number two, user has to remember two passwords or too many passwords. That problem is also solved because again, there is a common identity. User don't have to give different passwords for different applications. We use a common identity like AD or LDAP, which saves same username, same password. And number three, which is application is responsible for user provisioning. This is also solved as you just saw it in the last slide, where we are creating or provisioning accounts using a provisioning solution. There are different provisioning solutions in the market. I'm not going to say one name, but you can just look for an open source solution also. So all the provisioning and deprovisioning is also handled by the IDM solution now. So for hundreds or thousands of users, that is handled by that. So the application is independent of that and can just focus on the application logics or business logic. But we still have three problems remaining, which is number four, no single sign-on. Number five, application responsible for MFA. And number six, credentials are still sent to the application, like username and password, because the login page is shown by application, not by identity solution. We'll discuss how these other three problems are solved in an enterprise environment. Thank you. Welcome back. So now to discuss problem number 4, 5, and 6. Those can be solved by using delegated authentication. What does delegated authentication means? It means the application is not going to handle the authentication, but it's going to ask a special system, which is IDM solution, which is going to take care of the authentication. So instead of the web application showing the screen to log in, it's going to ask the IDM to handle that part. So that application actually doesn't ask for the username password. You can see on this screen, number one is the user goes to the application URL and tries to access the application. Application doesn't ask for the username password. The application just moves that request to an IDM solution or IDM system. The IDM system then shows a login prompt to the user, which is shown here as number 3, to get user credentials. And if the credentials are correct, then number 4, an authentication response is sent back to the application. And that is when the application actually shows the results to the user. So in this case, you can see that application is not asking user for the username password. Actually, the application doesn't care who's the user because it's not at all checking that information. The moment it receives a request to access the application, it just passes it to the IDM system and let IDM system deal with the authentication. And then if it's successful, then just show the results back to the user. Welcome back. So continuing our discussion on delegated authentication, the first topic is SAML. You saw in earlier slide that the solution is for identity solution and the web application being in the same data center. But most of the modern applications are not going to be inside that same data center or inside an enterprise. They are going to be in the cloud, as you can see here in this diagram. There is one application in AWS cloud and second application in the Google cloud. And then in the center, you can see the enterprise where the user and the identity management system, the SAML identity provider, directory service, which is Active Directory, and directory database is all in the enterprise, but the applications are in the cloud. It works fine if everything is in the same data center because there is a trust between the web application and the directory service or the IDM solution. But how the trust is built when an application is not in the enterprise, that is where SAML or any federation service is introduced. A trust has to be built between the application and the IDM solution, or in this case, in SAML's case, we call it SAML identity provider and SAML service provider. So service provider is someone who is providing the service, like web application. That's the service a user wants to connect to. And identity provider is someone who is giving the identity, which is the username, password, email address, phone number, other information. And this trust has to be built in advance. It doesn't happen at the same time. The service provider and the identity provider have to work together to build this trust so that the user can connect to the application using the identity of the enterprise. That is where SAML is introduced. It also solves the single sign-on problem because when a user connects to the application one and provides the identity to the identity provider, then the identity provider already knows that there is a user one, for example, who access application one, and now the same user wants to connect to the application two. So it's the same user, and the identity provider or SAML identity provider have already checked that information with the Active Directory, in this case, like a directory service, that this is correct username and password. And now the same user doesn't have to give username, password information to the same identity provider again and again. It just has to give it one time, and which is already authenticated, and then the user can connect to all the applications which have built a trust with the SAML identity provider in that enterprise. So that's SAML. Welcome back. So in the last slide, we spoke about SAML and how SAML works and what are the problems with LDAP just being in one enterprise and how that problem can be solved with SAML by creating a trust between the data center and the application in the cloud or in other data center. So here we are using the same diagram. It's just that we are showing one enterprise and one application, which is application 2 in the Google Cloud. On this slide, we want to discuss how single sign-on works. And there are 3 points here, which we will discuss first. How a user needs to avoid entering user credentials multiple times, and that is called single sign-on. Point number 2 is network user is already part of the AD, so that has to be used. And how this thing works in enterprise SSO, that's point number 3. So as you can see on the diagram, whenever the user types in a login information, it works for the first time because SAML gets the credentials, uses that to authenticate against directory service, which is Active Directory. And then for future applications, the SAML identity provider doesn't need to ask for the credentials again and again because it knows it's the same user and it's already authenticated by the Active Directory. And that is true for different web applications. It could be 10 applications or 100 applications. The SAML identity provider doesn't need to ask for the username and password information again and again. That is, in a way, a single sign-on. But does the user have to type the password even if the user logs into a Windows machine, for example, in a company? Example, a user logs into a company using Windows username and password. What happens next? Have you seen ever anyone typing the password even for the first time for any internal or single sign-on application? No. And how that part works? That part works because the SAML identity provider is in the same domain as Active Directory, and it takes those credentials when the first time user logs into the Windows machine. So even the first time when the user opens any web application after logging into the Windows machine, the user doesn't have to type the passwords or give the username because it's already in the same domain and SAML identity provider is connected with Active Directory. So it's already getting all that information with Active Directory and it uses a cookie to save the sessions for future connections. So that is the first part which I wanted to quickly explain you how single sign-on works for SAML enabled applications. Then the second part is identity authentication and authorization. And quickly, we want to just revise it, how these three things work in a SAML environment. So the first part is identity, which is all stored in the Active Directory, which is username, passwords, email address, phone number. So that is all stored in the Active Directory. And SAML identity provider is taking it from there. Number two is authentication. So SAML identity provider is using that in connection with the Active Directory as I just explained. And part three is authorization. So how does SAML know which user is having what level of authorization on which application? That is the responsibility of LDAP groups, as you can see in the directory. So there are different LDAP groups, and usually if the user is part of any particular LDAP group, which is configured in the SAML configuration, then the user is allowed to access that web application up to that level based on the authorization. So that explains the single sign-on with SAML how it works in an enterprise and what is the difference in identity authentication and authorization in SAML world and how this works. Hello everyone, welcome back. So till now we have discussed different authentication and authorization and identity solutions. We have covered LDAP, we have covered IDM, we have covered SAML for single sign-on. Now we are at a point to go to the next topic, which is OAuth 2.0 and OIDC. So before we start the topic, and which will take next few slides and next few minutes, we're going to discuss why we need OAuth 2.0 and why we need OIDC and what is the requirement to go next. If SAML can solve all our problems, why do we have to go for a new protocol or a new technology? So we're going to talk about few enterprise problems, to be exact, three enterprise problems. The first enterprise problem is microservice. So in this diagram or in this slide, you can see on the left side, we have organization data center with the SAML identity provider, IDP. We are not showing the LDAP or Active Directory, which is behind it for the identity verification. I'm just trying to keep it simple for understanding OAuth or SAML. Okay, so that's on the organization data center on the left side. On the right side, we have the cloud data center where we have our web application installed in the cloud. And in this case, microservice, we have the application UI as the front end, and then different backend functionalities are handled by different microservices, or you can say containers. In the current environment, a lot of companies use microservices like Docker or different containers, and they run on different containers, as you can see here: app service 1, app service 2, app service 3 with corresponding databases. So this is a very typical environment or architecture for microservice, where a user here is going to try to connect to the application, and the authentication request is handled by SAML. So I'm not saying that with SAML this is not possible. This microservice can be supported with SAML also, but it is much easier and much more convenient to use OAuth 2.0 and OIDC, and that is what we're going to see. So what is the problem if we use SAML here? One problem I can highlight is the SAML service provider is going to be in the cloud data center. Example, this one, application UI. And there has to be a trust between identity provider and SAML service provider, as we have discussed earlier. And that works, but what about app service 1, app service 2, and app service 3? And there may be 10 different app services. How is that going to build a trust with the SAML identity provider? Again, I'm not saying it cannot be done. It can be done, but it's more work to to build the trust between all the app services and have that kind of connectivity. That is the problem we're going to discuss. And this is enterprise problem one. We'll stop here and talk about other enterprise problems in next few slides. Welcome back. So now we are on enterprise problem two, which is for cloud applications. You can see in this picture, we have the same organization data center. We have same cloud data center one, but we have another cloud data center now, which is cloud data center two. And in this case, the application needs to connect to this REST API, which is on cloud on the top, but also another REST API, which is on premise. So it doesn't matter where is the REST API located. Is it if it's in the organization data center or in another cloud, doesn't matter. But when an application needs to connect, they need to use the username and password, which is going to be shared as a plain text. And that's the problem. That is why with SAML, this is not secure. And that is one of the main reasons why OAuth was developed. It was for the REST API. We are not going to discuss now how OAuth can avoid the problem, but just for your understanding, REST APIs and usage of REST APIs was one of the reasons to use OAuth and OAuth 2.0. Welcome back. So now we are on enterprise problem three, which is machine to machine or cron jobs. If we are running a cron job, which is connecting the REST API from cloud one to cloud two, or it could be on the same cloud where there is no user interaction, but a machine connected to other machine, there is no way to provide username password, or it's not secure way to provide username passwords. And that's where SAML is not the best solution. And that is where OAuth 2 comes into the picture. So going back to the same topic, anything related to REST APIs, OAuth is the best solution in the market currently, and we'll discuss that later. How? Welcome back. So till now we discussed three enterprise applications where we think that OAuth and OIDC will provide us solutions to solve the authentication and authorization problems. Now, a bigger problem is social media application problem. And social media application problems are the first or the most important problem which OAuth and OIDC solved. So in this picture or in this slide, you can see a user is trying to connect to udemy.com, finish a certification or a course, and then publish that information on LinkedIn in front of that user's network. So Udemy needs to connect to LinkedIn so that it can publish the information on LinkedIn. But the user doesn't want to give Udemy their username password for LinkedIn. So the username password for LinkedIn is secret to the user. So user doesn't want to share it with any application, but there has to be a way how Udemy could connect to LinkedIn and publish this information without knowing users username and password. And that is where OAuth comes into picture. And this is just one problem I explained. The other problem which all of us must have used is when you go to some third party application where you don't want to create your new account like username and password, and you want to use your Google or Microsoft or any of the email accounts, then that application allows it, and that is using OAuth. So you can connect to that application and log in using your Google like Gmail or Microsoft account or Yahoo account. And that helps a lot because we connect on a daily basis to lots of applications or like hundreds or thousands of applications on a regular basis, but we don't want to remember our new username and passwords, and that is where OAuth and OIDC takes precedence or helps us, because we just have to remember our Google account, Microsoft account, and OAuth and OIDC takes care of the authentication authorization in the background. And we will discuss how OAuth OIDC do that in next few slides. But this is the problem which I wanted to share with you first. Welcome back. So on this slide, we will talk about OAuth 2.0 and OpenID Connect, OIDC. So you just have to remember that OAuth 2.0 is for authorization or Z, and OpenID Connect OIDC is for authentication, Auth-N. OAuth 2.0 was published in October 2012, and it takes care of access tokens, which is for authorization information. It also includes scopes, roles, grant types, flows, and tokens, but you don't have to worry right now about that, because unless you want to implement OAuth 2.0, you don't have to deal with these things. And second one, OpenID Connect OIDC, which is for authentication purpose, was published in February 2014, which is approximately 2 years after OAuth 2.0. And OpenID Connect deals with ID tokens, which is about user information like usernames, passwords, and emails. So OAuth doesn't care about user information because it's just taking care of authorization. It doesn't need to authenticate users. So it doesn't need to go inside and check username and passwords, but OpenID Connect needs to do that. And we don't have to worry about OAuth 1.0 because that was the older version, and the 2.0 is not compatible with the older version. Welcome back. So in last slide, we quickly covered OAuth 2 and OIDC. And now coming back to the solution. So we saw a few problems in enterprise environment and in social environment using SAML, which could not be solved with SAML and IDM. And on this slide, we are going to explain how OAuth and OIDC can solve the problem. So we're just going to pick up one of the problem, not all the problems. But in this problem, we earlier explained that when an application UI connects to multiple app services, like microservices, then it has a problem because it doesn't have connectivity to the SAML identity provider because we use the SAML service provider. That problem can be solved once we have an authorization server. So it's typically the same server which is providing the SAML service provider thing, and there is the SAML trust between the SAML one. But in that change, the only change is we are using an authorization server instead of the SAML service provider. So this one gives OAuth 2.0 and OIDC support. And I'm not going to explain you the whole flow, although you can just follow it based on 1, 2, 3, 4, and 5, 6. But in summary, what the application UI and app service can do here is they can get the token and verify the token, which could be OAuth or OIDC based on authorization or authentication. And that solves the problem which SAML was not able to solve earlier.